feel it. Hello. Just getting ready. Eyes up. So we align. Just waiting a few people to get in the live so we can start. Yes. Okay, so we're going to start now. All right, we're going to start. All right, good. All right, we have a few people who have joined in, so we're going to jump onto the topic. So let's go. So hello everyone, welcome to today's TEKLIVE session. thrilled to see some of you who are already here, ready to dive into the world of the fascinating world of estimation model of software engineering. So our today's topic is beyond guesswork, mastering estimation models in software engineering. And this session is designed to be highly interactive. So I mean, you can write up your questions, and we are going to take them after the tech live. So I encourage you to write your question, and so you can see clarification after the presentation. And so for today, so estimation really is a crucial role, is a crucial skill in our field. Actually, it impacts project planning, resource allocation, and ultimately the success of our project. So today we'll explore various estimation models. We're going to briefly discuss about the strength and weakness. We're going to look at the practical ways and how to apply these models to real life scenarios. We're also going to cover techniques like expert judgment, three-point model, poker planning, and more. So we're going to discuss the pitfall and how to avoid them. And also, my goal today is for you to leave this session with a deeper understanding of how these models, how to implement them effectively in your workflow on your project. So thank you for joining us today. Let's get started and let's go. Okay, so just a little disclaimer. So before we dive deeper, so I want to set some expectation for today's session. So this session is going to be a little theoretical and can get a little bit complex at times. So if you have already done or participated in estimation exercises for a project, you'll find it easier to follow. I also want to clarify the distinction between software development and software engineering. So software development is actually a subset of software engineering. They're not the same. And software development focuses on writing code and creating application, while the software engineering in itself encompasses a broader scope. I mean, it encompasses a broader scope, including the systematic application of engineering principles to the entirety of a software lifecycle. So while software engineering can sometimes be boring to some, it can be incredibly interesting to those who want to understand the mechanics and the intricacies of software system, how they are built and how they are maintained. With that in mind, let's proceed and explore the fascinating world of estimation models. All right, good. So I'm going to introduce myself. So before we start, so I'm Tejas Pagwa. I'm an engineering manager at Klanik, Klanik Mauritius in the Offers and Expertise division, with a focus on research and development activities in the area of software as a service, on-premise solution around Java, Node.js, TypeScript, JavaScript, Vue.js, and Linux. I also architect and build scalable web applications. So I'm very technology agnostic with a passion for building things at scale and elegantly. So that's about me. And I had a question. So normally, before for this session, I wanted to have this session, but you can keep in mind. So how many of you guys here, how many of you have ever participated in estimation exercise? So such as can be poker planning, which is the poker planning. I'm sure many of you here might already be aware of poker planning. So it's the story point estimation and sprint planning, so or sizing. So I invite you to write your comments on the LinkedIn post if you want, so we can, Elsa is going to pick up them later on and ask me. Okay, so moving on quickly for the agenda today. So we will start briefly with what is estimation itself, why does it differ for everyone. We're going to start we're going to look at the importance of estimation in software engineering. So why is it important? Why do we do that? So we're going to look at the level of estimation. We look at the different levels at which estimation occurs, from high level estimate to detailed task level estimation. We're going to also look at the estimation model that are widely used in the industry. So for example, I'm going to talk about expert judgment approach. We're going to talk about the scientific method called the 3-point estimation and poker planning. And we're going to do an interesting exercise with estimation using a complexity matrix. So over the presentation, I'm going to talk about the best practice, and we are going to have a Q&A session. All right. So moving on. So let's quickly just so we just align. So we are good. Let's move on. So what is estimation in itself? So we are going to talk about what is estimation. Why does it differ for everyone? Okay. So normally, I mean, by definition, you're going to see in books or in Google. So estimation in itself is in software engineering is a process of predicting the amount of effort, time, and resource required to complete a software project or task within the project. So normally this involves assessing various factors such as the project scope in itself, the scope of a project, the complexity of a project, the team expertise, and historical data based on previous project, which is also the empirical method to generate accurate and reliable forecast. So we do that. So to ensure, to ensure the effective planning and execution of a project. So basically, just to give you, the definition of estimation. So just to put it in simpler ways. So let's talk about, let's see a visual example. So let's say you want to go from Marseille to Paris. So imagine you're planning a road trip actually. So let's say you want to plan it. So you need to figure out how long you need so in estimate you would try to know how much time you're going to take from Marseille to Paris. So the next thing you're going to do is you will know how much you want to know how much gas it's going to take. So you will also want to know along the way where you can stop. So you're going to look at the map. You're going to consider the different speed limits. Okay, so consider limits, so different areas you will have different speed limit, and also you will assess the condition of your vehicle. So, and because even and also potential traffic and others. So this process in itself. So what you're doing actually, you're predicting your journey from Marseille to Paris with a lot of estimation. So it's a lot like this in software engineering. You have different parameters that are taken into account to have a more precise estimation. So in software project, instead of the whole journey thing what we have been discussing, so we plan and build the deliver software. So we estimate time, effort, and resources needed to complete the task. So ensuring we reach our destination, which is the project completion in itself. So within time and budget. Budget is one important thing in software. So good estimation, just like to have a good road trip. So good estimation help us avoid surprises, unforeseen situations. So this is why I put it as the estimation in a simple way. So now we're going to see why actually estimation differs for everyone. So there are various factors. So normally I put it in four categories. So the first thing is about the experience level. So more experienced developers might have a better understanding of complexities involved, so leading to more accurate estimates. So the second, moving it, I mean, experience level is also related to subjectivity. Okay, so subjectivity is something about personal bias. So individual perception or optimism or pessimism can influence the estimate. For example, I'm a realistic person. Let's say I'm a optimistic person. I'm going to being an optimistic person is always going to estimate the time needed, whereas a cautious person is going to overestimate. Okay, so the third reason why it differs for everyone is because of the knowledge of a project. So knowledge on the project or the domain in itself. So difference in how well each person in the team understands the project in itself can vary the estimate. So the last part is about the techniques used. Okay, the technique used. Why? Because every engineer or developer has his own way to estimate. But if we use a scientific methodology, we're going to reach a more or less precise result. So different people might use different estimation technique like experiment, judgment, analogous, parametric models. So etc. So I was talking about when I said about the etc. is about the different estimation model. So I just mentioned about the parametric model, but I'm not really going to cover parametric model. I'm going to more talk about models that are being used in the industry right now. Okay, moving on. Let's talk about the importance of estimation in itself. Why estimation? Why do we do? Why do we do all this thing? Why is it important? Okay. Normally, estimation is a crucial part of project planning. In project management, the first phase of project, the whole thing is about project planning. Sorry. So is the first step of a project lifecycle. So the stage is normally where you plan everything from A to Z, from documentation to the actual software. So why do we do estimation is because it's part of a project planning. So the second thing is about it helps stakeholders of projects, so like project managers, development team, make informed decisions. So now what are informed decisions? So in software engineering, informed decisions are choices that are based on careful analysis. So normally I would say, careful analysis or relevant information that we have. So when we say relevant information is about using data, expert advice, or past experiences to guide decision. So this is about informed decision. Okay, to give you more context, let's take, for example, you want to decide the new programming language that you're going to use on a project. So to do that, the first thing, so let's say you have a project manager, or let's say you have an architect or an architect and a project and a technical lead in the team is going to, we are getting bored with JavaScript or TypeScript. We want to go on Rust. So what are you going to do? First thing first, you're going to research about the new language, the features, the benefits, the cons, and etc. You're going to consult experts in the industry. You're going to analyze data. You're going to analyze the risk and also test. So this whole thing is about informed decision. So the next thing is about why do we do it is because of setting realistic goals. So for example, you have you want to release this feature on feature X on 23rd June 2024. So you need information to set realistic targets. So also we do that to allocate resource effectively. So because we project managers have a tendency of saying, we put more engineer on the task to make it go faster. Okay, but normally it's not about this, it's about allocating resource effectively. So also, why do we do estimation is because to know the velocity of a project to be, what velocity do we need to have to complete a task or an iteration, and also about sizing. All right, so let's talk about something a little bit more complex. Is about the levels of estimation. Okay, so estimation in software engineering can be approached at different levels. So each providing various degree of accuracy or detail. So let's talk about the main levels. Okay, so before we talk about the main levels, let's see. Let's do a very short recap on the project life cycle. Okay, the project life cycle. What are the phases we have? So the first phase is the initialization. We have the planning. We have the execution. We have a monitoring and controlling, and we have a last phase, which is the closure. Okay. Normally, my area encompasses from planning to execution. Normally, the rest is the role of the project manager. Okay, so I wanted to briefly, before we deep dive, when you need to know which level of estimation is used at which phase of a project lifecycle. Okay, let's talk about the first level of estimation is about rough order of magnitude estimation. So, what is the purpose of it? So normally, the purpose of the ROM, so the rough order of magnitude, is to provide broad I would say a preliminary cost estimate for the project. So at this stage, normally we are not looking normally for precision. Instead, we are aiming to gauge whether the project is technically feasible or not. Okay, so if we have the capacity to deliver it, so this is why we do the rough order of magnitude estimation. So normally the accuracy is more or less 50%. Okay, have accuracy is less. We have accuracy is plus or minus 50%. And the level, I mean, the level of details over it's very high level. So it's normally, as I mentioned earlier, it's generally used for assumption and minimal detail information. Okay, so finally, let's talk about the usage. Well, so as I said earlier, so we use this so normally for decision making about whether the project should go ahead or not. So basically, uh, in technical jargon, so the ROM estimate normally acts as an initial, I would say, as a financial instrument. So I would say a financial instrument to guide whether if there's a go or a no go decision. Okay, so we use this in our normally use this so to know whether if we are going we normally for tendering for bidding, so we do whether we need to we do a high level estimation to go ahead or not. Okay, so moving on. So if you look at the visual summary of the project in the project lifecycle, so the ROM estimate is used at the initiation phase of a project. So you can disregard the others at the moment. So we're going to pay attention only at the initialization phase. So the purpose again is to check whether a project is worth starting, and again the accuracy is very broad. Okay. So moving on. So let's talk about the second level of estimation. It's called about the high level conceptual estimation. So the conceptual estimation. So just before I move, uh, um, let's talk about the purpose. Okay. So the purpose in itself. So normally high level estimation, high level conceptual estimation offers a more refined estimate than the rough guesses. So based on, I mean, initial requirements that we have, and it's actually not really, I mean, they are not really precise, but provide a more accuracy range around. Sorry, I missed it. So, the accuracy range is between plus or minus 30 to 50. Okay, so the details or level of granularity. So it uses the project scope. So we derive this estimate from the project scope, general requirements what we have, understanding, analogies from previous projects. So this is about uh, the level of detail, and the usage, as I mentioned earlier, is used in the second phase, which is about the project planning and the budgeting phase. And if you see it in the visual representation, it's about the second phase of a project lifecycle that we use the high level estimation. Okay, so moving on. The third level of estimation is called the preliminary top-down estimation. So preliminary estimate provides a more detailed estimate based on overall, on the overall project plan and architecture. So at this phase, normally you have more detail, more data, more knowledge, and from here you have a better accuracy of plus or minus 20 to 30%. And the level of detail, so in here we divide the project in major components or phases, estimating each component individually. And the usage, so it's used at the third level, it's called about the execution. Okay, so execution is about the phase where most of you are involved about the execution about the development part. Okay, fourth level. Okay, so detailed bottom-up estimate. So this method normally delivers precise estimate by breaking. I would say, breaking the project in detailed tasks. Estimating each of these tasks and then aggregating them. So you estimate. So when you are going to do the poker planning, etc. Okay. So the aim is here to aim more accuracy, plus or minus 10%. But 10% to 20%. And the details. So as I mentioned, we break the project in more details, and the usage normally is used on with scheduling. Scheduling what means about doing what and when actually. Okay. So visually, So definitive is used between the monitoring and the closure actually. Okay. The definitive one, sorry, the definitive one, the final, the most, the last, level of estimation. So this is the point where normally it provides a more accurate estimate to close a project. So normally it's used for billing, and this is where normally you have a plus or minus level of accuracy and the details. So based on the complete knowledge of the project, detailed design, and well-defined tasks, you can say, okay, now you can bill a client. Visual representation right now, so you can see definitive estimate is used at the last phase. Good. Let's move to now let's talk about the estimation model right now. This is about the estimation model, the estimation approaches that are commonly used in the industry. Okay, so let's talk about the first one. So it's about the expert judgment approach. So the expert judgment approach normally, it's the most straightforward estimate model that are used in the industry. So, here normally we rely on the experience and the intuition of seasoned professional. So that is, we estimate the time and effort required to complete a task or project based on the judgment and their experience. Okay, so the point here, normally you use your experience and the judgment. Let's, for example, to build an application, a single page application, I'm going to take, okay, based on my experience, I would say, okay, with a data store, the integration, the authentication is going to take roughly 10 man days. Okay, so this is based on my judgment and experience. So why the plus point here is quick. It leverages expert knowledge. So it leverages a deep understanding of experts who have handled similar projects. So an example is an expert. So as I mentioned, so an experienced developer is going to estimate accurately. And normally, this approach relies on insight, historical data, and elaborated calculation. The downside of it is it can somehow there's a subjectivity aspect, and everything there's also the bias part. Let's explain this in a better way. Okay, let's take an example. Let's take the example. You have a feature request. Okay, you have your product owner who came to you. Okay, you say, okay, no, I need to add the Microsoft Azure the Microsoft Active Directory single sign-on to an existing web app. So if you use the expert judgment approach, so what you're going to do first thing first, you're going to review the project requirement. What you do here, so to implement the SSO, what you have to do, so you review the requirement. So implement the single sign-on. You have to integrate it with existing backend system. You're going to ensure authentication and authorization, and also you need to update the user interface to support the single sign-on. The next thing what you have to do here is to identify expert. So I have identified the senior developer, the lead QA, and the UX designer. Okay, this is the second thing. You have a requirement, you have your expert, and the next thing is you're going to estimate. So estimate. So each expert is going to provide his or her own estimate based on experience or with similar projects. So this is an example again. So the senior developer, my senior developer, my SSO integration is going to take 60 work hours, so 1.5 weeks at 40 hours per week. The SSO is going to take 7.5 man days. The backend integration is going to take 3.75 man days, and the security implementation is going to take 3.75 days. In total, 15 man days. This is the senior developer. And the lead QA is going to say, the testament plan is going to take 2.5 days, man days. The security testing is going to take 2.5 man days, and again, 5 days. At the last, the UX designer, our guy who is going to take his paintbrush and come is going to say, okay, to design the login, so it's going to take me roughly 2.5 days, and again, user testing and adjustment, 2.5 days. So if you aggregate all of this, and coming to a consensus between everyone. So the development, 50 man days, backend integration, if you aggregate everything again, so sorry, so my bad. If you aggregate everything, it takes a total of 32.5 days. So what you have done here, you have not used, you have used your knowledge, I mean the developer, the senior developer, the lead QA, and the UX designer has given their estimate based on their expert judgment. So other models that use historical data and expert judgment is the top-down estimation model and the bottom-up approach. Okay. Moving on. So I'm going to talk about an interesting scientific model that I really like myself, because there's mathematics in this one. It's a more realistic model. A model that we use. I normally appreciate coming from a project management background myself. So what is the 3-point estimation model? Normally, it's also known as the PERT technique. So it's called a program evaluation and review technique. So it's normally a probabilistic estimation technique that is used in product management and software engineering. So this statistical tool uses optimistic, pessimistic, and the most likely estimate to calculate the weighted average estimate. I'm going to tell you, don't worry. So how it's used, So as I mentioned earlier, so there are 3 parameters in the 3-point estimate model. So what do we have here? So normally we have 3 parameters. So we have the optimistic estimate. So normally the optimistic estimate is the best case scenario of completing, of doing this task. So you have a task. So normally, what is the best case scenario? So assuming everything will go smoothly as possible. Okay. The most likely estimate is the most realistic estimate based on expert judgment and experience. And the third estimate is called the pessimistic estimate. So it's the worst case scenario considering potential delays and unforeseen difficulty. So normally, again, so you have a most optimistic one. So let's say, okay, an optimistic person is going to normally in a team, you normally if you in all team you have normally the most pessimistic person, and you might also have an optimistic person, and you also have a realistic person, and you're going to do an average between all these 3. Okay, so again, best case, worst case, and most realistic estimate, and the formula is the time estimate. So it's the optimistic estimate plus 4 multiplied by the most realistic estimate, and the plus the pessimistic estimate, everything divided by 6. Okay, to come here, there has been statistical precision, there has been research going on to how come up with this formula. So let's take an example to better understand this model. So let's estimate the task here. So let's estimate the development required to implement a new feature in a mobile app. So okay, so using the 3-point estimate process, let's, in the best case scenario, assuming that all elements align favorably, so everything goes well, everyone, no one in your team doesn't take any leave, everyone is on time in the office, everyone is coming to the stand-up, there's no one I don't know, not pushing their codes, everyone is doing everything on time. So the optimistic estimate here is 5 days. And the most likely estimate, so the realistic one, so if a project manager, I have a developer who tends to commit his commit and push his codes a bit late in the afternoon, and he also have a tendency not to push his code. He commits and he doesn't push. So I have someone who might have put a sick leave or put a leave on Friday. So the most likely estimate is going to 8 days. And considering the worst case situation, like, okay, you know, there's having been, like for in the example for Mauritius, we have unforeseen situation. We have been having unprecedented situation like cyclones, rain, etc. So considering all of this, we say, okay, it's going to take 12 days. So if you map all these parameters into the formula again, so you're going to come into, so if you have like for, so you take the optimistic, so what were 5, sorry, apologies, with 5 plus 4 multiplied by 8. So the 8 was for 8 days again. So just to come back here, 8 days plus 12. 12 was the most pessimistic. You sum everything, you do the bird mass, is bird mass here, bracket of division, multiplication, addition. Yes. And you divide everything by C, you come to 8 point plus or minus 8.17 days. This is scientific. Moving on, let's talk about poker planning. Okay, poker planning. I'm sure many of you all is already accustomed to this one, but it's used in the industry. It's an estimation model which uses effort and as metric. Okay, so story point 1, 2, 3, 5, 8, etc. So poker planning normally is a consensus-based technique, so used in our agile. So in agile methodologies, not in only Scrum, in agile methodologies, to estimate the effort required to development tasks. It involves team members normally using cards. So you normally use cards to with numerical values to represent their estimate. So the purpose again of poker planning is to facilitate discussion and to reach a collective agreement on effort needed for tasks. So how it works. So we are going to look also for an example, but let's talk about the theory first. So each team member selects a card representing the estimate. So the card is really is revealed simultaneously. So normally the PO, the product owner, is normally supposed to do that. So you see normally you use you use tool to do that. To do the poker planning. So the cards are revealed simultaneously and discussion are held to understand the different perspective and angle why you have been having different values, I mean, different estimate. So again, so preparation, so you have a product owner or the project manager represent the user story or task to be estimated. Normally, we use the, as I said earlier, 1, 2, 3, 5, 8, 13, and 20 as estimated, for effort range. There is an effort estimation round. So normally each team member privately, so you don't say beforehand. So you have to reveal. Normally the PO reveals the card simultaneously. There's a discussion and there's a re-estimation if needed. Okay. So let's take an example. So again, so preparation, you have an estimation round, you have a discussion, and you have a re-estimation if needed. Okay. So let's take again the feature we have been talking earlier, adding the Active Directory single sign-in to the login of a web application. So the prep. So the first part, the PO is going to narrate the story. So guys, we need to implement the SSO for Microsoft Active Directory, integrating the backend, ensuring authentication, and updating the UI. Okay, so the developer is privately select their cards. So developer A says, okay, I would say, okay, we're going to talk about this part a bit later. So 8.5, what does it correspond to? So I say, okay, it's going to take like 3 days. Normally, it involves modifying a lot of files. It's a new feature. There's migration to be done in the database, and there's also a request to be done. So 8 points. Developer PC says 5, and developer C says 13 points. So there's a discussion going on. So developer say, okay, estimate moderate complexity based on previous integration. So why the developer says, okay, why he has said 8 points. Developer B says, okay, 5 points. He believes that this source is simpler due to familiarity of existing systems and Active Directory. His personal view on the situation, and developers say, this is, normally this is in this three is the pessimistic one, highlights the potential integration issues, security concern, and justifying the estimate. So there's a re-estimation going on, so aligning everyone. So everyone, after the discussion, everyone comes to 8 point. So there's a consensus that is reached. So the team aligns on the effort considering both implementation and potential challenges, because developer B did not take into account the security concern, nor developer A. And developer A only based on the complexity, actually, but did not take into account the security concerns. Okay, nice. We are going to do an exercise. We are going to do an exercise on estimation. So normally, I'm going to bring up my amazing file, my amazing Excel file, which we're going to do some calculation. Okay, so we're going to do an estimation exercise with a complexity matrix. Okay, yeah, don't worry. We're going to talk about what is the complexity matrix. Okay, so the complexity versus the duration matrix. So normally, the complexity is normally where you align the complexity with a duration. So actually, in this example, what we are going to talk about, I have done the equivalent. So for example, by complexity 1, it's actually going to take 1 hour. So the example what we are going to take is something related to man hours. I was doing a high level estimation. So a high level estimation whether the project was feasible or not. And I'm going to show you my approach and how I reached to a point whether the project was feasible or not, and how much time the project was supposed to take. Again, this was a magnitude of the magnitude was high, so this was a high level estimation. So again, so complexity 1 is normally 1 hour, 2 is 2.5, 3 is equivalent to 4 hours, 5 8 equivalent to 8 hours is 1 work day, 1 work 9 hours, normally 1 hour for discussion and resource loading and leveling. Complexity 8 is say 16 hours, equivalent to 2 man days, and 13 is equivalent to 40 man hours. Okay, so equivalent to 1 week. So this is the matrix. So before we jump into the exercise, I wanted to make you understand the complexity versus the duration matrix, what it is. So again, there's an equivalence here. So you do the we're going to, normally this is what is done actually when you do poker planning, when you do the what is the Fibonacci sequence, 1 2 3 5 7 8 and 13. Okay, so let me open my Excel file. Okay, just bear with me. I'm opening my Excel file. Okay, just getting there. Okay, so this, I'm going to use this. Sorry. All right. Okay. Okay. So what are we going to do? We're going to do the exercise here. We're going to do the exercise. Okay. So again, just to give you a bit more context. So this project, this is, I would say, I have anonymized a lot of things. So I have anonymized a lot of data. And removed a lot of things to give you an understanding, but this was a real estimate. So we had to upgrade a project from Angular, a previous version, a very primitive version of Angular, to Angular 14, version 14. So we had to decide whether this project was feasible or not, and we wanted to know whether we would go ahead or not. And to give you more information, what we did actually. So first thing first. we had to I had to detail the different stages of projects. For example, initialization of a Git repository, redesigning of the application architecture, planning the migration strategy. So again, the context was about migrating an Angular application from a primitive version to a newer version. So checking npm packages, the migration, and the JavaScript file, what we had to migrate from JavaScript to TypeScript, because Angular 14 uses TypeScript, of course. There was the style migration, we have the GDPR compliance, and etc. Okay, so this is again a high level estimation, but I'm going to show you how we did it and what was wrong. There was actually something wrong happened, but I'm going to show you an engineering way and what was the mistake I did and how did we fix it. Okay, so quantity wise, so if you do normally, I mean, this is one, and I'm going to do the effort. So we have seen this earlier. So the complexity versus the duration. So in hours, so we have seen earlier. So 1 hour, 13 is 14 hours. Okay. So if you come here again, so the quantity was 1, so effort was normally 1, and this effort point, so the effort point of the application results of evaluation. So for the correct architecture was 8, designing 13, and creation of a migration plan estimated to be a little less complex was 5. Okay, I'm not going to go into the details. I'm going to show you what was done. Okay, so normally there was a mapping, so there was, like, for example, uh 23 packages in the package per the JSON files. What was supposed to be the effort, so the effort to upgrade it was normally 3 points. 3 points if you do you go in the chart again, so it's 4 hours. This is actually an overestimation. I wanted to be a little bit pessimistic here, because we in when you estimate, normally it's preferable to overestimate than underestimate. So I did this. So there was 24 files, and again in terms of files. So for example, there was like 270. So for example, here there was 272 files. The effort to rewrite these into TypeScript was 5, which is like 5, which is equivalent to normally again 1 man day. Okay, so if we put don't worry about the TDD part. So, and again, so what was done? So normally what you're going to do, normally if you do it if you use the mechanic way, so normally you're going to say, okay, 1 multiplied by 1 is going to be 1. So quantity, so I'm going to do the sum here by aggregation. 1 uh, 1 multiplied by 8. So sorry, I'm going to do, so I'm going to do this multiplied by this. Okay, so let's do this. So I'm going to do this. Let's do a little bit of this. Okay, what did I do? What did I miss? Sorry. Apologies. What happened here? Just so, yeah, sorry. Again, there was an error. My apologies. Let's do it clean. Let's do it the cleaner way. Okay, so I did this. Let's do this. Multiply by the quantity, multiply by the effort. You have the number of effort. Okay, so again, so if you do this and you say, okay, this multiply by the quantity, so effort multiplied by quantity, so 69, this is it, and 246. Again, you do this again. The effort was rewrite multiplied by this again, 375 point. Let me check why I did. Okay, yeah, nice. Okay. Again, so now here I have the effort. Okay, so normally what I have here is now the effort. So the total effort in terms of point. So no, I forgot the GDPR. Let's do a little bit more. Sorry, let's do this. Yeah, of course, because the columns are different. That's why we are having this effort. I know. Again, the colon, so we do this, should have put, so if you multiply by 2, again here, and we do this multiply by 2. Okay, so normally you have a total effort in terms of points. So what you're going to do, you're going to do the sum. So you do the sum of this column. So you say, okay, and you do till here, okay, and you have 4,600 and 4,642 points. So normally, the approach here, normally, if you do the mechanic way, this is wrong. Okay. So if you take, for example, 75 components, if you're going to rewrite it into TypeScript, and you're going to have 375, and you're going to calculate, is wrong. So normally, let's say, for example, so sorry, so H2032, what I wrote, yeah, sorry, this was here. Normally, let's put these here. So let's put these here. Sorry, again, my bad. Apologies. Let's do the calculation here. So equivalent to J. Let's do. I'm doing the real time exercise with you. So what I did know. Sorry, it's J. No, it's I. Apologies. Let's put I here. So if you do the exercise, so the average number of effort points per week 5 developers can produce is 25 points, assuming that a developer is going to produce 5 points. So 5 multiplied by 5 developers is 25 points. The total effort for migration for the whole development project is 4,642. And if you divide it by number of weeks is 185 weeks, and the total number of days is 928 days. And this project was supposed to take 3 years. How? There's something wrong here. There's something wrong. And normally, to fix this, what we did normally, I'm going to show you the right way. So what happened actually? So I'm going to do what I did in exercise. I'm going to show you the real way actually. So normally, sorry, when I did the exercise, I didn't take into account the TDD, the test-driven development, into account. So I'm going to put it now into account. So to show you what happened. So normally, if you there's not much difference here. I haven't taken the TDD again. And if you take into account the test-driven development, it's 5,442 effort points. Again, coming up to 4.19 years. Imagine you upgrading a project into 4 years. How you're going to cater for this? So normally this is wrong. Normally what you should be doing, you need to use a complexity matrix and do a mapping. Why mapping? So again, one hour again is equivalent to 1 hour. Again, 8 hours is equivalent to 18 2-man days and 16 hours. 13 effort points, which is the complexity, is equivalent to 1 day. Normally, I did a calculation. So normally the C5, which is again the C5 is C5 is C colon 5 is this one, and the total effort to do this was 2. Sorry, was 8. And if you do it, I did the conversion into hours. So this is effort. If we look into the table here, what is 8? 8 is this is M6, if I'm not mistaken, sorry, is N6 is right. So this is the reason, sorry. What I did, there was an equivalence. So we did an equivalence, we did a mapping, and after this, we came up to 890 effort points normally. Okay, so when you do again the exercise using this effort, the effort point normally, if you do the mapping, you're going to come to this point. Again, I'm going to give you more context now. So let's take this example. How do you reach 11.5? So if you take 23 23 quantity. The effort is 3. The effort is 3 point. So the complexity is 3 point, and normally the equivalent is 4 hours. So if you come here again, you will see that C11 is the field that we are looking into. C11 is 23. C11 is 23 multiplied by N5. N5 is 3. N5 is 3. Sorry, we are going to take the hours. So 3. So we know it's 3 points. It's going to take 3 effort points. 3 again. So 3 we divide it into hours. So multiply 23 multiplied by 4 divided by 8, you get 11.5. If you do the same thing here, if you do the matrix, so if you do the calculation, so 23 multiplied by N4, which is equivalent to effort point is M4. Yes, M4 is equivalent to 2.5. So again, N4, this is N4. And what you're going to happen here, you're going to do divided by 8 hours. Normally, if you don't divide it by 8 hours, you're going to have it into it's going to give you into hours. What I did here is going to give you into man days. Okay, so I did the 8 was hours. If you don't again, so if we do again, we multiply by, this is into man days. Man days, if you so this is a more precise so if we do it into man days, so we do it into hours. So if we do this multiplied by 8, we're going to give it into hours. Actually, this is for 7,124 hours, and this is into man days. Normally, if you don't want to do this, this is an exercise. I mean, it's a scientific thing. It's a quite complex, but if you use a complexity matrix, you're going to reach this result actually. So this was about the exercise I show you. Yeah. Okay, so we have question coming up. Excellent. Okay, this was the exercise. So coming up back again to my presentation. So let's move here. We are running a bit short in time, so we are going to take up questions now, guys. So I'm going to take questions from you guys. So I invite you to should we have questions, Elsa? So
hi everyone. Yes, so Matthew just asked how you in the exercise you just did, but I think he got the answer himself
okay,
right there.
yeah,
I guess this is yeah.
I saw the question. So Matthew, hi. So each project, so a very important point, each project has its own complexity matrix. The complexity matrix will differ from team to team and again from project to project. So normally it might not be the same. So it's again based on your team velocity. So it's also based on your team, the level of your team. If you have, for example, 2 is equivalent to you have inside. So okay, 2 is 2 days instead of 16 hours. Yeah. So 2 effort point might be equivalent to 2 hours, and for another team it might be equivalent for the half of it is 4 hours. It's again based on the level of a team, and again based on the complexity of a project. So if you have more questions, guys, please shoot. I'm here to take your questions. Meanwhile, I'm going to drink some water.
So right now we don't have anything, but we're waiting for the questions if there are
Okay.
any.
All right, cool. Yeah, I know I went a bit fast. I mean, there was a lot of information to assimilate. Yeah, estimation always remains very complex, remains very scientific, remains very, again, I would say it's based on the project, based on the team. Yeah. So question, guys, if you have anything, you can reach me later also.
We have another one there.
Yeah. No estimate. Yeah, I heard. I'm normally I haven't dived into. Yes, I heard of it, but not really dive into. But we can have a discussion later on this on this, Mathieu. I will be no estimate. Yes. Yep. No estimate.
Yes, I guess we can put your LinkedIn in the comment
Yes.
section, and then people can talk about the topic where the oh yeah, you did the job perfect. Yes.
Yes, exactly. So yes, guys, I'm reachable on LinkedIn. I'm also active on Twitter. If you want to reach me on Twitter, so my handle is Nirvan Pagua, and on LinkedIn you can reach me out on Tejas Pagua. This is my account, and yes, we are within the timing. We are. My estimate was good.
I guess, yeah.
Estimate was good.
Um,
We are just in the time.
yeah, I don't see any more questions, so thank you, Tejas, for this nice live and deep and tough conversation. Thank you very much.
The pleasure is all mine. Thank you, everyone. Thank you, Mathieu, for the question. Thank you, Elsa. Thank you for the streaming team, Manon and you, Elsa. Thank you, everyone. Thank you, Klanik, and thank you, everyone. See you soon, and bonne soirée à tout le monde.
Bye bye, Tejas. Thank you.